this is circular dynamics lecture number 11. Let us have a quick recap of what we did in the previous lecture. Anyone recollects what we did in the previous lecture? Can you tell me now? What did we
In a
do?
vertical circle.
Yes, well done. We were doing with a vertical circle, and we were dealing with the first type of motion on the vertical circle, and the first type of motions on the vertical circle happens to be motion on the outer surface of a body. So we are dealing with a round body probably, which is kept on ground, something like this. Kept on ground. It could be a cylinder, it could be a sphere, and the motion is happening on the outer surface. This is the outer surface and the motion is happening over there. And we had seen that if the body is at rest at the top and we give it a very slight push, what are the things that could be asked? Velocity at any given angle, what is the normal reaction, what is the tangential acceleration, and what is the centripetal acceleration. And we derived the formula for all of these. How did we do that question? We followed the simple advice: draw the free body diagram. We always do that. Then we wrote the equation in 3 axes, 3 directions. The first is the tangential one, the second is the radial one, and the third is in the perpendicular direction. No force acts in the perpendicular direction. We got a set of equation, and I told you to remember this formula. The formula for velocity is root over 2gr into 1 minus cos theta. You must not forget this at all. There's something that should be there in your mind. See, bacha, when they gave a so-called very tough question in JEE Advanced, it's not a tough question. It is just comprising of small questions put together. And if you can remember concepts like these, the velocity after falling down a distance or angle theta is root over 2gr into 1 minus cos theta, your life becomes very simple, and you would be able to tackle a very difficult problem. You will be able to solve that problem once you come home. I know that. But in the examination hall, what matters is, can you do it? Can you do it in the time that is given to you? Time is the factor that decides whether you are in the top 100 or top 1000 or top 10,000, or you are not selected at all. After 10,000, selection hardly means anything in the general category, especially. That matters. So if you remember these small things, and that is why I highlight them, you should do good. Now, once you remember a general formula, you can always formulate a special formula. Now, see how physics compresses itself, and how you can understand other things from what you are understanding now. The formula that we did in the last class was root over 2gr into 1 minus cos theta. Now my question is, does this formula look similar? Does this formula look similar in some cases? Now, if you go to the question where go to the first chapter, now this is how you relate things, and this is how you can remember things in a better way. If I had a bob or a ball of mass m which is dropped from a height h, and I'm just going back to the very first chapter. We have also done this question in work, power and energy by law of conservation of energy. We have done it by work energy theorem. We have done it by V square is equal to U square plus 2AS over there. If it is at rest here, and as you can see, the case here that I'm doing, case number 1, is similar to case number 2, which I have drawn here. Here also the blob is at rest. The only difference is, instead of falling vertically down, dum, it is falling like this. Pum. See? Pum. Right? Now, if I ask you, with how much velocity does it fall down? So when it reaches down, What is the velocity here? Obviously, after touching down, the velocity becomes 0 because of the collision. We have still not done collision. Don't worry, we'll do that. What is the velocity with which it falls down? Do you remember that? Remember? What is the velocity with which this block falls down? This block of mass m falls down on ground. The velocity is root over 2gh. Yes or no? Do we understand this?
Yes, sir.
Now, this formula, if I call this formula number 1 and if I call this formula number 2, these two formulae are same. Can anyone tell me how are they same? Can anyone tell me how are they same? These two formulae are same. Can anyone tell me how are they same? And it is right there in front of your eyes. You can see it, you can feel it.
It is replaced by radius. Yes, compound.
H is replaced by something else, but why it is replaced by that thing? H is replaced by r into 1 minus cos theta. But why is it replaced by that? Anyone?
Different, sir.
Hanak is saying they are height from the reference point, and Hanak, I think what you want to say is, now if I try to compare case number 1 with case number 2, in case number 2 we have to find this height h. This is the height this gentleman has fallen. I hope everyone can see this. This is the height this gentleman has fallen. And you can simply see that this height that this block has fallen down is nothing but total height r. This is the total height r.
R minus r cos theta.
It is r minus r cos theta. So this formula and this formula are exactly same. Nothing has changed. The only thing is here the value of h is r into 1 minus cos theta. Nothing changes. The basic principles remain same everywhere. So the formula is still same. This is not a new formula that we have derived. Am I clear with what I wanted to say? Am I clear? Can I have some raised hands?
Yes, sir.
Formula is same. Now once you get the value of v, the rest of the problem can be easily solved because v square by r becomes your AC. You multiply it by m, that becomes your centripetal force, and from that centripetal force you can find out the value of normal reaction. I also gave you a question in the last class, which I hope you have done this. The only thing extra that I asked in that question was to find the value of A, and I hope you understand and remember. How do you get the value of this A? How do you get the value of this A? The total axis. This is nothing but under root of. See, Bacha, I'm not able to hear you. This is AT square plus AC square. Do we all remember this? So once you get the value of AT and AC, everything is solved. Let us now move on to today's class and see what else we can do here. Now, I told you what we are going to do here is to solve different cases and to understand what are the basic questions that are asked. And these are the only questions that will be asked. Trust me on that. The only thing is the way in which they are asked would be different. Sometimes it would be asked straight away. In JEE Advanced, don't expect a straight away question. They will always ask you in different ways. For example, they will not ask you what is the velocity with which it falls. They'll ask you in some other way. They will give you the values of some velocity. Is this velocity possible for this block to move on this surface? Then you will have to think what that question has got to do with what we have studied in the class. And that is where you have to apply your brain, and I can't help you. I can only tell you what all questions can come. what all types of questions can come, but the range is so vast that I can't cover each and every one, because if I just change a single thing, it becomes a completely different question. So I'll tell you what are the basic things. With those basic things, you can do everything that is possible. Now, one thing that I told you was this. Now, again, I go back to that motion on the outer circle. And one very peculiar thing will happen on this motion on the outer circle. This is O and this is R. I hope everyone is drawing as soon as I am writing. Now, I leave this block. See, we are doing only one particular case where this block is at rest. Remember, I can make different questions by changing the value of the velocity at the highest point. I can make it something else. I can make it 2 meter per second. It becomes a different question. I can make it 4 meter per second. It becomes a different question. But the basic concept remains same. Am I clear? Can I have some reason that we understand this? Okay. Now, this is at rest. Good. Now the question is, if I give it a small push, same thing, does it keep on moving along this circular groove, circular path, the outer surface, or at some point, as we discussed in the last class, will it leave the surface? What will happen? Will it keep on moving on this curve, or will it drop, or will it leave the surface? What is your opinion? What will happen? Will it keep on moving on this, or will it sometimes at
Leave
some
the
point
surface, sir.
it will leave the surface? Yes, everyone understands that it will leave the surface. Now the question is, at what point it leaves the surface and with what velocity it leaves the surface. And I will give you I'll give you a minute to think about it. The point. Who is this gentleman? Okay, I muted all. I was getting some disturbance, so the class should have needs to unmute, right? So I'm asking you to unmute. So just unmute yourself. Okay, done. Great. Again, I lost where I was. Okay.
What point?
Yes. At what point is it going to leave? Let me call this point as B. Oops. Not good. Let me call this point as B. This is the point where it is going to leave. So the question is, at what point it leaves? And you will have to tell me how are you going to find out this. At what point it leaves? It leaves the circular track. So basically I'm asking you what is the value of this theta. Once you know the value of this theta, you know the point where it leaves and with what velocity it leaves. It will leave with some velocity. With what velocity it leaves. Now before going on to solving this question, you have to understand that when this circular motion is happening, the body is free. The body is free in the sense that the body can leave the circular track. The body can leave the circular track. The body can leave the circular track. Since the body can leave the circular track, we call this type of motion and we add something in that motion. What is that thing that we add in this motion? I hope everyone is following me. As you can see, the question that we are doing right now is that the body is going to leave at what point it leaves. So the body is free to leave this circular path. since the body is free to leave the circular path, I will add one more thing in the heading of this. This is not, and remember, this is plain English, this is not confined to circular path. So basically I am not restricting it to follow circular path. It is following circular path because of his own wish. He wants to follow circular path. No one is forcing him to follow this circular path. So such type of motion is known as circular motion, which is not confined. In other words, this is motion on the outer surface of a body, not confined to a circular path. That means it can leave the circular path. It is free to leave. How can I make it not leave the circular path? So I can give you an example of a motion which is confined to a circular path. I am forcing it to move on the circular path. I am forcing it to move. See, I've got a ring. These are the sort of ring normally girls wear. Even boys wear also kada and rings. Now, if this is a ring, it has got a predefined circle. Now, if I have a bead, I hope you understand a bead. Everyone understand what a bead is? Small beads that girls have in their bangles. Beads. Now, if I have a bead in this ring, now this bead, since it is put like this, this bead cannot leave the circular path. Whatever happens, this bead cannot move out. Just cannot move out like this. So this bead which is on this ring is moving on a circular path and it cannot leave the circular path. Such type of motion is known as motion confined to a circular path. I can't leave this. But if this bead is at the top, it is not kept like this, it is here, then it can very well leave the circular path. This is known as motion not confined to a circular path. I'll give you one more example. You have seen a roller coaster. Shoo. Now this roller coaster, if you look at this roller coaster, it has rails. If this is the rail of the roller coaster is put like this. So whatever happens, it just cannot come out of this rail. So whenever it is going on top and you might feel that you will fall down, you will not fall down. There are two reasons and we will see that rail is holding it from the top, the rail is holding it from the bottom. This is a motion confined to a circular path. The roller coaster cannot leave the circular path. Am I clear? You understand the difference between confined to a circular path and not confined to a circular path? Can I have some raise hand that you understand this?
Yes, sir.
Boys on the right, girls on the left. Okay, got it. Okay, so right now, the motion that we are doing, the motion that we are discussing is motion not confined to a circular path. That was what I wanted to insist on. Now the baton passes on to you. You have to tell me at what point it leaves the circular path and with what velocity it leaves the circular path, and you have got a minute to win it. Let's see how you can do this. I'll give you a minute to try, and that is important. Trials are important, then only you understand what difficulties are you going to face. If you don't try, you will not understand the difficulty, you will not understand the question, you will not even read the question, you will only read the answer, you will mug up the answer. That will not help. You can clear JEE Main like this. You can definitely clear NEET by this. In NEET wala class, I never gave those guys how it is done. I just gave them the formula because that is what they require. Even for JEE Mains, you don't need to think. JEE Mains is just like NEET. But in JEE Advanced, you need to think sometimes. Think and tell me how it is done. A minute, 2 minutes. Okay, I hope you have thought about it. Anyone, any idea how we are going to do this? How are we going to find out what is the basic thought that you have? At what point it leaves the surface? How will you do it? Anyone has any idea? Remember, no idea is right, no idea is wrong. It's all about what you are thinking and how you can imply that idea. When Ola was started, everyone was thinking this is a stupid idea. You don't have a car, you don't have a vehicle, and you are asking an unknown person to pick an unknown person and drop it at an unknown place, and you will make business out of it. Utter nonsense. But see, right now is $100 billion company. Uber. No idea is stupid. No idea is wrong. Tell me, how do you intend to find out? What are the thoughts? What will you do to find out at what point it leaves? Why will it leave? But it's not able to continue on the circular path, it will leave. It is same as leaving this circular track is same as imagine that you are on a bike or a cycle and you are trying to turn your cycle on this circular track. If your speed is very fast, will you be able to make that turn? Yes or no? We have seen that. If you want to turn on a circular track, the maximum possible speed. Can you even tell me what was the maximum possible speed? If I am trying to turn on a circular track, and see now everyone is looking back. No one remembers it. If you don't remember it, you will have a difficulty because remember, bacha, whether it's JEE Mains or JEE Advanced, it's more a question of time rather than you solving the question. So, if you're trying to turn on a circular track, what is the maximum speed possible? What is the answer?
Under root mu s RG, sir.
Under root mu s RG, that is the answer when I'm trying to turn it using friction only. What if I use banking of the road? Then what is the answer?
Under root tan theta RG.
So under root RG tan theta. If my speed is more than this, what will happen?
Flips, sir.
It slips. I will not be able to move on that circular track. I will slip. Same thing is happening here. On the top, it is at rest. The velocity increases slowly. But at some point, the velocity will become so much that it just can't keep on moving on this circular track. It just can't keep on moving on this circular track. And that is the point where it leaves. That's it. That is hint number one. The velocity becomes so, to understand why it leaves, the velocity becomes so much that it just cannot continue on the circular path. No one can stop it from leaving now. But when the motion is confined to circular path, it will keep on moving. And then we will understand why it is moving now, why it can't leave the path. It can't leave the path because it is restricted. That is one reason. But then how will it keep on moving? Then we will think, okay, this is the reason it is keeping on moving. Right now, no one is restricting it. Speed becomes too much, go. You leave the circular path. So hint number one, to understand it in the language of physics, why it is leaving the circular path. One reason is it is not confined. The second reason is the velocity becomes too high. Since it is falling down under gravity is continuously pulling it down. Velocity increases. At some point, the velocity becomes so much that it has to leave the circular path. So velocity is too high. But that velocity is too high. How do you relate this with this question. Velocity becomes too high. It leaves. Now, when something leaves, what happens? Oops. This is a flat surface. Keep something here. I have to find something soft. Otherwise, my screen will. Okay, this is good. This is a body which is kept here. This body is too small to be seen. Let me find another body. Okay, this body looks good. This is the body that is kept here. Tongue. You will see. This is my surface. This is the body that is kept here. When it is kept like this, they are applying a force on each other. Yes or no?
Sir.
Let us forget about friction because there is no friction here also in the question. So what do we call that force between these two bodies that they are applying on each other? Oops. I hope nothing has been damaged. Okay. What is the force? I shall have to keep it away from my laptop. What is the force that they are applying on each other?
G, sir.
Mg is not the force that they apply on each other, beta. M is the mass, G is acceleration due to gravity, mg is the force of gravity that Earth applies on them. They don't apply on each other. Hanak is saying contact force. Yes, this contact force can be resolved into two components. One is the normal reaction, another one is the friction. They're applying contact force on each other. Yes, Hanak, that is correct. And right now we call that contact force. Since there is no friction, we will call it as, we'll just look at the perpendicular component, which is normal reaction. So they're applying normal reaction on each other. They're applying normal reaction on each other. Now what happens if this leaves? What happens if this leaves? What happens to the normal reaction? What happens to the normal reaction when they leave their contact? What happens to the normal reaction? No one understands this? When they're in contact, they are applying normal reaction force on each other. When they leave contact, then what happens? When they leave contact, their normal reaction becomes 0. And you must remember this because wherever you encounter a question, where they ask you or tell you that somebody is leaving the surface, is leaving the contact, it is flying off down, the normal reaction becomes 0. That is the most important thing that you must remember for any body which is leaving contact with any other body. Do we understand that? Can I have some raised hand that we understand this? So that is hint number 3. I've given you 3 hints. First hint, it is not confined, so it can leave. This is just like that Balaji telefilm ke serial when they put the camera 5-10 times. So that is your first hint. It is not confined, so it can leave. Second hint, again Balaji telefilms, boom. Second hint, the velocity becomes too high, it cannot continue. Balaji telefilms. 3, the normal reaction becomes 0. Now I've given you all the hints. If you can't solve it now, try. Again, a minute to minute. I'll give you a minute. Okay, welcome back. Let me solve this for you. I think you have already told me how to get the value of V. Again, I will repeat myself. And the first thing that I'm going to do, the first step to solve any problem is to draw the free body diagram. That is what I'm going to draw here. The first thing is the weight mg coming down. The other one is normal reaction, and you will now say that the normal reaction will become 0. Okay, it will become 0. I am just drawing a general diagram to begin my conversation. Now, this weight mg is going down, so I will resolve it into two components. I hope everyone knows what are the two components. What are the two components? One is towards the center. That component, I think, is mg cos theta. Yes or no, the blue component?
Theta is equal to tan inverse of L by R.
What is L? What is R? I don't understand L. What is R? And this component is mg sin theta. The first equation that I am going to make is the force in the tangential direction, that is equal to m into at. How much is the force in the tangential direction? Tangential direction, the green force, that is equal to mg sin theta. Right, m and m get cancelled themselves, so my tangential acceleration becomes g sin theta. Done and dusted, not asked, but since I have got the answer, I will just mark it. The second equation, now we come to the business end of this problem. The second equation, the equation in the centripetal direction, fc is equal to m into ac, that is also equal to m into v square by r. Everyone knows it. Now that has to be equal to what? Give me, look at the diagram and tell me. Yes, mg cos of theta inward towards the center minus n outwards. That's it. That is equal to mv square by r. Every one of us knows this, but we also know one more condition here. One more condition we know here. What is the condition? Balaji Telefilms. What is the condition? That
n equal to 0, sir.
This n equates 0 because it has to leave the circular path.
M cancels.
M cancels. So I have my first answer.
R is equal to g cos theta.
V is under root of gr cos theta, and you must never forget this second equation. That should remain with you throughout your life, that with this velocity it is going to leave the circular track at angle theta. Now the only question that remains is what is the value of this theta. But before going on to that, it's my honor and privilege to introduce you with the third equation, and the third equation is in the perpendicular direction. Do you find any force in the perpendicular direction? Perpendicular direction
No,
is
sir.
like this.
Zero,
No,
sir.
sir. So just leave all this force, but you must always remember that you have to make equation in the three directions. We are done and dusted with the three equations. What should I do next? 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 No one has any idea. Number 4 step. I will
block displaces with L distance.
I will apply law of conservation of mechanical energy from point A to point B. And when I apply law of conservation of mechanical energy from point A to point B, I will make the exact similar equation that I had made in the previous case. From there also I can get From there also I can get the value of a v. V will be equal to root over how much? And that is the power of remembering. If you don't remember, right? Gone case. You will lose a lot of precious time, and the precious time once gone will never come back. So this v will be equal to root of 2gr into 1 minus cos theta. Yes or no? Do I have some raised hands there that yes sir, this should be equal to this? Nothing has changed. Yes or no?
Sure.
Now I have two v's in my hands. One is the red v, one is the blue v. Should these two v's be same or different?
Sir.
Same. Equate
Equate
this.
them.
Equate them. Yes. Now I apply simple common sense. Equate them. And give me the value of theta. That is the angle at which this gentleman has to leave the circular track. It has become too hot? No. His speed has become too much to carry on moving on this circular track. And that is what the answer that I'm looking for, at what angle it leaves. And never forget that angle, because that is the most important angle that you will ever get to know in physics in your lifetime. What is the value of that angle? It's a very simple equation. Everyone can solve it. Time is running out very fast.
Cos
What is the
inverse
value of this
2 by
angle?
3, sir.
Yes, beta?
Cos inverse 2 by 3, sir.
Yes, the value of that angle, cos of this theta, will come out to be 2 by 3. Will come out to be 2 by 3, or theta will come out to be cos of inverse. No, not cos of inverse. Cos inverse 2 by 3. This is the angle at which it has to leave the circular track. There is nothing in this universe. Even Lord Krishna cannot help him, her, or it continue moving on this circular track, because it defies the laws of physics. When Lord Krishna reincarnates, when Vishnu reincarnates as Lord Krishna in this two-dimensional, three-dimensional world, he has to follow the laws of physics in this universe. The laws of physics in this universe says that when the angle becomes cos inverse 2 by 3, nothing in this universe can help him, can make him move on the circular track. The only thing that can help him or make him move on the circular track is when I confine the motion to the circular path. Remember, normal reaction has become zero and it has to leave. The normal reaction has become zero, it has to leave. Now I will have to restrict it somehow, hold it tight. Hold it tight. And somehow make it to move on this circular track. That will be a question in the coming classes. In the next class, we will be confining ourselves to motion not restricted to the circular path. Once we will cover that motion completely, and we understand that the motion is not confined to circular path, then we will move on to the simpler motion. The simpler motion is the motion which is confined to the circular path. That is the class for today. We have arrived at some fantabulous results. At what velocity? No. At what angle it leaves the circular track? It is not confined to move in a circular path, remember. And with what velocity it moves. Remember, both the green equations are same. You can find out the value of v from equation number 1 or equation number 2. It will leave us with the same result. The result is root over gr cos theta. You can now put the value of cos theta and give the value of v. What is the value of v? You can just put the value. Wrong color. You can just put the value of cos theta here and get the value of v. So v will become root over 2 by 3 gr. Do we understand this? V will become root over 2 by 3 gr. Do we understand this? I've just put the value of cos theta and I land up with this result. This is the maximum possible velocity. After this, bye-bye circular path. I am leaving. The only way I can move on the circular path is You confine me, and you will confine me in the coming classes. So that's it from my end today. I hope you like this class, and we'll move on to other motions. Motions are same, but the headings are different. Again, we will be confining ourselves to motion, not confined to a circular path. Meet you in the next class. Take care and have a good weekend. Enjoy. Enjoy also. Watch some TV, play some games, but study hard. Take care. See you.